Hello everyone, this is Henry of the Smart RN channel. In our video today, we are going to look at the nephron. Now, the nephron is the major functional unit of the kidney. It is that unit which actually filters out blood to remove waste and to result in urine formation. Each kidney has approximately 1.2 million nephrons in the left kidney and the right kidney. Now, nephrons are either cortical nephrons or juxtamedullary nephrons. And the difference between these two nephrons is brought about as a result of this section here referred to as the loop of Henle. In cortical nephrons, the loop of Henle is very short, and as such, it only enters the outer surface of the renal medulla. Remember, we talked about the parts of the kidney, and we said we have got the outer the renal capsule, then below it we have got the cortex, and the inner layer we say is referred as the medulla. So the cortical nephrons have a very short loop of Henle that only enters the outer surface of the renal medulla. On the other hand, juxtamedullary nephrons have got a very long loop of Henle that goes deep in the renal medulla. Cortical nephrons account for 85% of the nephrons. And what does this mean? It means that most of the work of filtration is carried out by cortical nephron. The remaining 15% is carried out by juxtamedullary nephron. Now, kidneys are supplied by blood by the renal artery. Remember, the renal artery is a branch of the aorta. When the heart pumps blood and goes into the aorta, one of the branches of the aorta is the renal artery. And this one, renal artery, delivers approximately 20 to 25% of the cardiac output to the kidney. The cardiac output is the total amount of blood that is pumped by the heart in 1 minute. So it means that 20 to 25% of that blood which is pumped by the heart is delivered to the kidney by the renal artery so that we can have filtration of waste from this particular blood. Now, when the renal artery enters the kidney, it subdivides into arterioles until we have what we refer to as efferent arterioles. Efferent arterioles are those arterioles that deliver blood to the kidney. They are the ones that deliver blood, to the glomerulus. As we are going to see, the nephron has what we call the glomerulus, and the glomerulus contains a network of semi-permeable capillaries and that actually carry out the blood filtration. So blood filtration is done in the glomerulus, which is made up of a network of semi-permeable capillaries, and this glomerulus receives blood from these efferent arterioles. Now, efferent arterioles are the ones that now remove blood from this particular glomerulus. After blood has been filtered now, it gets out of the glomerulus via the efferent arterioles. So what I'm trying to explain here is this section here. We have the renal artery delivering blood from the heart and from the aorta. And this renal artery subdivides into arterioles, and we have the efferent arteriole that delivers blood to these glomerulus here. So the glomerulus is just a network of semi-permeable capillaries which actually do the work of filtration. And once blood has been filtered, it leaves the glomerulus via the efferent arteriole. So that's what we refer to as the efferent arteriole. Now, this efferent arteriole is later on going to become what is referred to as the peritubular capillaries, and these peritubular capillaries are later on going to deliver the blood to the venous system so that they can flow back to the heart or other parts of the body. Now, when we look at the renal, when we look at the nephron, we divide a nephron into two. So we have this section here, which is referred to as the renal corpuscle, and this section here, which is the tubular section. So the nephron has got the tubular section and the renal corpuscle. The renal corpuscle is made up of what we call the glomerulus. And we have just said that the glomerulus is a network of semi-permeable capillaries which do the actual work of blood filtration. Then this cup-like structure here is referred to as the Bowman's capsule. So the glomerulus is located inside the Bowman's capsule, and this space is known as the Bowman's space. So once filtration has taken place, the glomerular filtrate collects in this space in the Bowman's capsule before it begins to flow into this particular tubular section of the nephron. So this is the renal corpuscle that's made up of the glomerulus and the Bowman's capsule, and there is this Bowman's space that performs the work of collecting blood of glomerular filtrate after it has been filtered. Now, we also, as we have said, we have the tubules. This tubular section of the nephron is divided into the proximal convoluted tubule, the loop of Henle, and the collecting duct. The loop of Henle is further subdivided into the descending and ascending loop of Henle. So when we come to the to the tubular section here, this is what we refer to as the convoluted tubule. So from the convoluted tubule here, we have this loop of Henle, and remember we said that this loop of Henle helps to differentiate between the cortical and juxtamedullary nephron. So in the cortical nephron, we say it is very short, and juxtamedullary nephron, we say it is very long. So this is the loop of Henle, and this loop of Henle is made up of the descending loop of Henle and the ascending loop of Henle. And when this ascending loop of Henle comes up there, we have what we call the distal convoluted tubule. The distal convoluted tubule continues until we have the collecting duct. So this is where the tubular filtrate is collected and exits the nephron. Remember, this is now where we have that renal papilla. So it goes from the renal papilla and goes into that particular minor calyx down there. So this is what we refer to as the collecting duct. Now remember the efferent arteriole. The efferent arteriole is the one that moves blood out of the glomerulus after filtration. But when the efferent arteriole comes on this side, it winds along this particular nephron to result in what we call peritubular capillaries. So these are peritubular capillaries, and we are going to see that there is reabsorption, there is secretion, there is excretion, until we have urine being formed in that particular region. So this is the part that does the actual work of filtering blood in the kidneys. Now, we have a term referred as the glomerular filtration rate. Now, this is the rate at which the glomerulus is able to filter blood. And we normally have the glomerular, the normal filtration rate is approximately 125 milliliters of urine per minute. That's what the glomerulus can actually filter. And when this glomerulus, or when you have this rate of filtration, then we have 100% filtration. So this is what we achieve. This is what we aim for our kidneys to do. But you find that when one of the things that we look at when we are considering whether the kidney is functioning properly or normally or not is the glomerular filtration rate. So we always look at it. It must be over 90%. If the glomerular filtration rate is over 90%, then our kidneys are performing well. But if the glomerular filtration rate is below that 90%, then actually something is very wrong. So this is the structure of our nephron, and we are going to see what exactly happened at each and every section of this particular nephron when we consider the nephron physiology. So that brings us to an end of this video on the nephron, and from here is a goodbye.